This lesson will be focusing on what we call type 2 binary compounds. And when you look at the different elements that we're working with, you notice that the element that I'm working with is iron 3. In other words, a transition metal. Just to remind you, transition metals are found in the center of the periodic table, and they're unpredictable on how many valence electrons they have in their outer shell. And we use this Roman numeral to tell us how many electrons there are, or in other words, what the charge is of your element. So in this case, we have iron 3, which tells us it has a positive 3 charge. I look at oxygen. Oxygen is in the third to last row on the periodic table, and I know that it has a negative 2 charge. Now in the past we've always put O2. At this point I just want you to write down the chemical symbol and what charge they have. So what we're going to do is we're going to draw the valence electrons for both of these. So we have iron. It tells us that it can lose 3 electrons, so we place 3 electrons to iron. Remember, it wants to have a full valence shell, and so it's easier for iron to lose 3 electrons than to gain 5. And then we have oxygen. Looking at the periodic table, it tells us that we have 6 valence electrons. And so what we can tell right here is this is very similar to a problem that we've done with the type 1. We have iron going to donate its electrons to the oxygen. Oxygen will want to have a total of 8. We notice that there's still 1 electron that iron has that needs to be lost, which means that we're going to have another oxygen, another oxygen take that electron. Let me erase this last one. And see how it goes from there. So this electron will be taken on by the oxygen over here. But now the oxygen is not got a complete valence shell, which means that it requires yet another iron 3. Remember, it has 3 electrons. So one of those electrons is going to be given to the oxygen. Iron still has 2 electrons left, and it will want to again get rid of those, and it just so happens that oxygen wants 2 electrons. And so we now have a total of 2 irons. So iron 2 and 3 oxygens. So we place that as O3. So we have Fe2O3, and this is called iron 3 oxide. It's absolutely essential that you put down what the charge is. Otherwise, we don't know which type of iron it is, and we won't know what the chemical formula was. So let's try one more. This one is a little bit easier. This tells us copper has a positive 1 charge. Bromine, looking at the periodic table, has 7 electrons. So let's draw the the dot structure. We know that copper has 1. With this here, bromine, looks like it just needs 1 more electron. That copper is going to donate its electron, so we have CuBr, because both of them have a full valence shell, and this will be called copper 1 bromide. So we can look at it in a different way. We can look at how would we write this how would we write the chemical formula when we're given the chemical name? Well, this tells us that we have lead, which is Pb, with a +2 charge, and we have chlorine, which we know has has 7 valence electrons and wants 1. So it's still easier for me to actually draw these out. So when I look at my chlorine, I can tell that one of those electrons from the lead will be moved over to this chlorine, thanks to chlorine being highly electronegative. And because This chlorine, because lead still wants to donate one electron, this chlorine will take on that electron and both have full valence shells. So lead 2 chloride would be written as PbCl2. Don't fall into the trap, which a lot of students do, where you say Pb2Cl because you're thinking that 2 tells you how many atoms there are. That is not the case. It simply tells you the charge. So this chemical formula would be PbCl2. Let's try iron 3 sulfide. If I look at iron, we know that it has a +3 charge right here, and sulfide I know has a -2 charge. So that means that iron has 3 electrons. Sulfur has 1, 2, 3, 4, 5, 6. And you can tell this is very similar to the problem we had as our first problem. So these 2 electrons will be torn off by this sulfur, and the sulfur will hold on to that. But we still have 1 electron that iron is wanting to get rid of, and so we need another sulfur. This electron is going to be lost and gained by this sulfur, but that means this sulfur still has a single electron, and so then we add yet another iron, and that means that this electron can move to this sulfur, this electron can move to that sulfur, and this one, that we have Fe2S3. Okay, so that would be the chemical formula. There are a couple of other ones that are unique. Whenever you have silver, and this is something you should make note of, silver always has a +1 charge. It is not a transition metal in that way because it will always have a +1 charge. Chlorine, we know that it has a minus charge, and so that means we have silver with 1 valence electron, chlorine with 7. Therefore, you will always have just 1 electron being donated to the chlorine or torn off, and we will have AgCl. All right, that's the chemical formula. That's the same case for zinc. Zinc will always have a +2 charge, just something you have to memorize. And in this case, we can see that zinc with its 2 electrons, one will be, chlorine can take 1 of those, and then it requires another chlorine to take the last one. And so in this case, we will always call it zinc 2, Zn2Cl. Okay? And that's the end.